Hey, I'm Nathan Ness. I'm from the Cloud Native Apps Business Unit at VMware. And today I'm going to talk to you about what's new in Kubernetes 1.7. So 1.7 came out around the end of June timeframe. And so, the four key areas of focus here for the 1.7 release was around security, extensibility, runtime, and then running the application. So a lot of pet workloads were focused on, to include stateful sets to provide some updates around that. And so that's what the four key areas that we'll talk about here today. And so starting off with security. And so the main focus on this was a lot of around enterprise features for deploying Kubernetes in an enterprise type fashion. The first one is actually encrypting secrets. So prior to 1.7, you actually had to provide another method of encrypting your etcd database. So etcd is actually the key value store that Kubernetes uses to store all of the metadata. And so now in 1.7, they added out-of-the-box encryption for data at rest for etcd. It's still recommended to actually encrypt it in other methods like disk encryption inside of that, but you can actually use the encryption here to actually encrypt some of the secrets or API passwords that you're passing into your applications when you're using secrets inside of Kubernetes. Certificate rotation is another thing they added, but this is also an alpha feature, and they wanted to provide this as far as being able to use TLS bootstrapping with the nodes. And so the node is going to actually talk to the API server, and it could talk to an external CA. The CA could be sitting on the master node, but it'll basically have the trusted certificate to actually join the cluster as a worker node. And so this is something for being able to refresh the certs, making sure that the cluster is trusted for all of the workers that are joined into this cluster. This does require TLS bootstrapping though when you're using certificate rotation for the Kubernetes workers. So limit node access is another thing that they wanted to focus on as far as role-based access control as well. This is something that they want to have the nodes of whatever they're scheduled on them to only have access to those nodes. So the compromise of a worker would not give it compromise to the entire cluster inside of Kubernetes. So the example here is the node can modify its own status, but no one else's status within this cluster. So all pods really inside of a worker node, have access to all other pods by default and for default networking. And I believe the next talk will actually go into detail around that, around network policy. But again, this is something where the node should specifically have access to the pods that are scheduled on them, not necessarily volumes that are created outside of it and secrets and so on and so forth. Audit logs. So audit logs were essentially just standard out going into a specific log, but now we have the ability to actually put them into different logs. And the main goal of this was for compliance reasons. If I want to have my audit logs sent to a very specific tool, I can use these syncs to do that. So I can redirect different logs or different types of logs into different logging mechanisms. So I might have application logs going into Wavefront or FluentD or some type of log insight maybe. But then I can have audit logs going into another compliance, compliance checking and for auditing. Extensibility. So extensibility is something where I still want to use kubectl as the API or the Kubernetes API, but it's not coded into Kubernetes. And so I can actually code that by using a plugin, or maybe this is going to be some complex operation that I have, and I just want to make it very simple inside that plugin.yaml. So then I can just call plugin.yaml and make it a very simple API call rather than this complex operation that I'd have to make maybe mini kubectl calls, or maybe it's just not coded into the CLI extension yet. Another thing, I can register new API groups. And so again, if I want to use the kubectl API for maybe some extra policy that's not necessarily built into Kubernetes, I can register that API with the Kubernetes API server and actually call another plugin or another program that's going to do like maybe some extra policy for compliance reason again. But it's not necessarily coded into the Kubernetes API, but I want to still have that seamless API call or from the single API master. I can certainly use, this feature is beta in Kubernetes 1.7, but I can register different APIs or different plugins. This is used a lot for network policy that's not necessarily implemented in there. I can use the register new API groups calls. Webhooks. So webhooks is something where, again, they're focusing on security and who's allowed to do what. And so if I want to be able to, provide access to certain functions inside of a cluster for a developer and then restrict certain functions, I can use webhooks for this. And so each policy would be built in so such that, let's say, let's record to an external system. Maybe that's going to be in the pod spec, or verify there's no secrets in the environment variables. I can actually program that in, and it'll actually deny the API call when I submit that into Kubernetes. The last one is I can check against LDAP credentials. So if I want to verify against your role and your group within the organization, if you're allowed to do the certain pod spec or the certain network policy, webhooks would be a great function to be able to do this, where it can be basically an accept or reject call. So runtime, won't go into this in too much detail here just because there's a very specific talk on it, but no major changes, but it actually went GA in 1.7. And so NSXT can actually be used to implement this pod level networking. So if you want micro-segmentation for pods, you can use the network policy feature to this, and it'll actually implement NSX security policies inside of your Kubernetes environment for pod-to-pod level micro-segmentation. Cryo. So this is something where I talked about, Docker's been around for a long time, but when we're looking at Cryo, we're actually just programming Kubernetes to be, a series of standards. So Kubernetes wants to get away from actually just coding to a individual like Docker API or Docker runtime, or even like from the NSX perspective or networking perspective. They want to get away from actually coding directly to that, just for stability. So each new version of Kubernetes provides new features, and so they want to actually have the underlay have just code to this plugin. Here's what's supported inside of Kubernetes. You code to this plugin, and then we'll support you as the underlying feature, such as Docker or Rocket, or same thing with NSX with Flannel or Calico. They want to actually just code to this standard. And so this is going to be a huge shift inside of this, where it's an alpha feature today. But again, it's going to provide minimal overhead because they don't necessarily, again, want the, all the Docker goodness that's in there. They just want a very slimmed down runtime. And so that's what Cryo is supposed to entertain. Running applications. So the stateful set. So I think it's good to go over a stateful set. I didn't do it in my last talk either, but a stateful set is actually for the Cassandra workloads or the pet workloads. It spins up pods in a certain order. So when you're doing master-slave applications, it'll spin up the master first, and then subsequent slaves on top of that. But what we provided in 1.7 is stateful set updates. Prior to this, you were not allowed to update the stateful set. You would just destroy it and create a new one. But now we can actually create updates. And you can actually do what's called a partition. So you can say, how far do you want the stateful set to update? And it could be 50%, it could be 60%, but you can create that partition to make sure the update is going well and make sure everything's okay. And then you can continue the update to the rest of the stateful set that's deployed. So again, stateful set also added parallel scaling. So as I said before, the goal of the stateful set was to actually do a very ordered deployment, and it'd be very asynchronous, so 1 to 1 to 1. And now I can actually do parallel scaling and scale out pods in a many to 1 ratio. So daemon sets here, what is a daemon set? So a daemon set is also, if I have a worker node and I have a daemon set, there's going to be one pod running for that daemon set. So it's a one-to-one relationship. So if I have a daemon set maybe for logging, so every time I spin up a new worker, a daemon set's going to deploy maybe a wavefront pod on each one of those workers. And when I take down a worker, the pod is not rescheduled. It's just, there's only, again, 1-to-1. So it's not like a replica set where if I have a replica set and there's supposed to be 5 pods running, it will not reschedule those when a worker goes down. And again, in 1.7, they added automatic rollouts to this as well. So now I can actually update my daemon sets across my cluster. And again, so maybe a new version of Wavefront coming out, I can update that daemon set across the cluster here. So storage, again, we talked about this in the last talk as well, but the ability to map local storage as well. And so this is kind of more of a developer feature. Maybe I have a Kubernetes cluster on my laptop just spinning up with kubeadmin or something, or kubeadm. This would be a great tool to actually test maybe some storage API calls and so on and so forth. Okay, any questions? I can take questions afterwards as well.